Hello guys, this is the lesson before the last one. As you know, next week, the 10th, is the last time that we're supposed to submit homework to you. So I guess after Wednesday, that will be your last assignment that I will be due on Thursday. But for us, the last day that we're supposed to send work to you is supposed to be the 10th of June. So that means that on Wednesday, you're going to receive one more lesson, and that homework has to be handed in the following day on the 11th. Anyway, today we're doing exponential growth in decay. Exponential growth in decay has to do with exponential function. Remember, the exponential functions are the one that increases rapidly, all right? The difference between the linear function and the exponential function is the linear increases at a constant rate, while the exponential function increases rapidly. It doubles up, okay? So now growth means increase, decay means decrease. As I always give you a warm-up problem, all right? In this case, we are talking about you guys want to buy a car, okay? And the car they're going to buy costs you $22,000. Now, you got a loan, okay? So you can pay the car in 3 years, but you have to, they're gonna charge you a 9% interest rate, which means that you're gonna pay more than what the car cost. So I wanted to do this, remember, because now we're doing everything online. It's not the same thing as doing in class. I modified the lesson and I asking you, okay, how much will you pay after the 3 years, okay? How much will the car cost? So I'm leading you through the whole thing here and giving you step by step what you have to do. So for instance, all right, the question is, okay, complete the chart below, all right, to find out how much you own for the car at the end of the 3 years loan. That means that if you buy it for this, at the end of 3 years, you're gonna pay more than that because you gotta be paying interest. So I lead you through the problem by doing the first year for you. So what you have to do is, if you pay $22,000, okay, and now you're gonna pay 9% of interest a year, remember the 9% always have to divide it by 100 to make it a decimal. So if you notice here, I divided, okay, 9% by 100 to get 0.09. So remember, every time you have a percentage, okay, you have to divide it by 100. Okay, in this case, because it's 9% divided by 100, you get 0.09. So when I multiply these two, that gives me the interest, okay, for that year. So that means at the end of that year, I will own $23,980. Well, actually, that's how much money I will have paid at the end of that year. But because my loan is for 3 years, I have to calculate how much will I pay for the next and for the following year, okay, for 2 years more. So to calculate how much money I own after the second year, okay, what I have to do is I have to calculate the percentage of interest to the new amount, because at the end of the year I own this. So that's why I started for you here this amount for the second year. When you multiply that times the percentage of the interest, which is 0.9, you will get $2,158 with 20 cents. Okay? So now you have to add this to that so you can get how much money will you have paid for the second year. I mean, in 2 years. So if I add this 2,158 with 20 cents, I will have paid at the end of 2 years $26,000, 138 with 20 cents. Remember, that's what you're supposed to, okay, round your money up to cents. If they don't ask you to round it to nearest dollar, you round it as near cents, because money can be presented in cents. Now, at the end of 2 years, that's how much money I will have paid for the car that cost me only $22,000, okay? Now, I have to do one more year, which is this new amount, which is $26,000, 138.20 times 0.09, okay? that will give me the interest for the third year. And that amounts to, let me write it right here. Okay, so just for you to know and not to waste any time, that will give me 2,352 with 44 cents, because I rounded up. All right, so that means that this amount, which is my new taxes, okay, this one, I have to add it to the amount of money that I own the second year. All right, so remember, the interest for the second years I added to the total of my first year. So now the third year interest, I'm gonna add it to this one. So if I add 2,352 with 44 cents to the previous year, okay, so that will give me the total amount of money that I will have paid after 3 years. So if I add that up, that gives me $28,490 with 64 cents. That will be my answer. Okay. Cost, initial cost times the interest, that's the percentage, you give me the interest. So if I add that to my original cost, I get the amount for the first year. Then I multiply that against 9% to get the new interest, and I will add that to this amount to give me the second one, okay? And I will keep doing that until I reach my goal. Here it was only 3 years, so that wasn't too bad. But think about it, guys. What about if you buy a Tesla, right? A Tesla, and the Tesla costs you $100,000, and you're gonna pay that in 10 years. You gotta do this 10 times. Can you imagine if you're gonna do this 10 times, you're gonna be tired and you're gonna take a lot of time and a lot of work. So that's why we introduce you now to the exponential growth and decay formula, which is this one right here. If you notice here, this formula for that is A, which is the capital A, that means the total, equals A, little a, the lowercase, which means the initial cost. One, the one is the 100%, that's the amount that represents 100%, and the R means the rate or the interest. If it's an increase, a growth, okay, you're gonna add it. If it's a decay, you're gonna subtract it. So one or the other one. R, like I say, is the percentage, and T is the time. So what I'm going to do is I'm going to do the same problem by using my formula. So the only thing you have to do first is identify your variables. And in this case, I know that my little a is going to be the initial cost, which is $22,000, okay? Now, R, which is the rate, remember that one is part of the formula. You can't do anything about that. That has to be there all the time. Is 9%. But because we have to divide that by 100, R become 0.09, which is the one that is right here. And now T, which is the time in years, is how many? 3 years. So what I'm going to do, I'm going to substitute I, R, and T into this equation, and I'm just going to evaluate. So A, which is the capital A, equals little a, which is the initial amount, $22,000, parenthesis 1, and you know that this is a growth because you're gonna pay more, okay, than when you actually pay for the car because of the interest. So there has to be an add, a plus 0.09 elevated to 3 because 3 is T times. So I have A, which is 22,000, I have R, which is 0.09, and T, which is 3. And I put that just like that in the calculator, guys. I'm gonna do it once so you can Remember how to do it? Now, remember, guys, we only evaluated, I already clean my memory. Remember, always clean the memory of the calculator, because when you graph, it will be nice if you go to the table, that table will begin from 0. So you gotta go to, so since I'm all evaluating, I'm not graphing, I'm just going to do like a normal calculation. So I'm gonna put 22,000, hold on, I wanna see when 22,000, all right, parentheses, 1 plus 0.09, close parentheses, and elevated, so I'm going to use this key, up arrow to the third power, or 3 years. And I just do enter, and that will be my answer. And if you notice, I get exactly the same answer that I got before doing like the old school. So remember what I always tell you guys, that not everything before calculators came available, we used to do everything mentally, like the long way. So as you can see, because we're talking about cents, this is the 10th and this is the 100th. So that means that the thousandth is a number greater than 5, so that 3 becomes 4. That's why the answer is $28,490 with 64 cents. All right? So the answer is exactly the same one as before. So, because today the topics is growth and decay, so we are going to use this formula. So we're not going to forget about this, and now you're going to use that. So this made my life a lot easier, okay? So just think about, how difficult it would be if we don't have a calculator, right? To calculate all this. So for instance, look, number 2. An impressionist painting increases, okay? Increases, that means going to be plus, okay? In value at an average rate of 9%. So that's the value of art right here. If the original cost, okay, of the painting on the museum of art was $1,500, that's gonna be your little a, your initial cost. What was the value of the painting? So we're looking for the value, which is gonna be the big A, okay? To the nearest dollar, that means that we want no cents. But now, they ask you at the end of 20 years, that's going to be T. Can you imagine if you have to do like this for 20 years? It will take you a long time to do that. So the best thing to do is use our beautiful formula. So what I'm going to do is I'm going to identify my values of my variables, or you can just do them from here, okay? The only thing is, remember, the rate is 9%. If you divide that by 100, it should be 0.09. Remember, always, that's what I highlighted right here to you. Always change it to a decimal. So because you identify your values, you don't have to, you don't have to line them up, okay? So you're gonna use your formula. Capital A equal your initial, which is little a, in this case is 1,500, parenthesis 1, we know it's plus because increases, 0.09 elevated to the value of t, which is 20. And you put it just like that in the calculator, okay? And if you put it, I'm gonna do it again so you can see what I'm doing. I'm not graphing, okay? So I don't need to go to y equals because I'm not graphing. So I'm gonna clear that up. So 1,500, parenthesis, 1 plus 0.09, close parenthesis, elevated to the 20th, all right? And I just do enter. And that should be my answer. Okay, now, was it 20? Oh, because I forgot my point there. I see my decimal point. That way it came out like a big number. That's like 23 spaces. That's a huge number. So it's my bad. Let me do it again. 1,500, parenthesis, 1 plus 0.09, close parenthesis, elevated to the 20. Much better. Because it says rounded to the nearest dollar, I don't want any cents. But remember, because here, the value of the first number at the decimal point is 6, and 6 is greater or equal than 5, so that means that the 6 becomes 7. I'm gonna add I'm gonna add 1 to this value right here, because we want no cents. If they would ask you to the nearest cents, that would be 62 cents, because that's my cents right here, and that because that's greater than 5, that becomes 2. But they're asking me to the nearest dollar, so that means no cents. So my question should be up to here, to the unit. So the answer is 8,407, okay, dollars. So the answer should be $8,407. That's how much the paint is gonna cost, okay? So that's my answer. I did it in one step rather than do it like in 20 steps, right? So let's continue, let's move on. Okay, so that was the one, just put that in the calculator. Remember, you're not graphing, okay, just evaluating. So let's go on the back. Let's do the next one right here. So now I have, this is one problem, you have to answer 3 questions. So you have to actually interpret what the problem is talking about. First of all, it says, the Ryans save $4,000 which they want to invest for their son's future college expenses, okay? They have $4,000. They invested $2,000 in each of the boys' account, which will increase, which will accrue, that means plus, okay? Because remember, you're saving money in the account, you're making interest. So you're gonna make money, so that means it's a plus, it's an increase of 8.25% of interest, okay? So think about it. Your parent has $4,000 and you're gonna open 2 accounts, $2,000 in your account and $2,000 in your sister or your brother's accounts. Both of you are gonna make this much of interest, okay? So the interest is gonna be the same for both of you in the same amount. The only thing is that the years are gonna be different, because if I continue with the problem, right? The problem says if James will graduate high school in 9 years, okay, 9 years, that's gonna be T here, and withdraw his money, okay, after 9 years, how much money will he have for college? Remember, now, the little a here for him is not 4,000, it's 2,000, because he's getting 2,000 and Michael also is getting 2,000, okay? Because his parents are splitting this amount between both kids. Now, the rate is going to be the same for both of them, because the rate is 8.25, and if you divide that by 100, you will get 0.0825. 0.0825. Now, the only thing that's going to change is T, because T here for James is 9, and T here for Michael is 14. So I have to use 2 different equations, right? So first of all, okay, capital A, which is the total amount, equals my little a, which is the initial amount, $2,000, parenthesis 1 plus 0.0825 elevated to the 9th. And that gives me, remember, I'm not going to waste any time, just put that in the calculator just the way I showed you before, and that will give $4,082 with 8 cents. That's how much money James will have after 9 years, which is double, all right, of the amount, more than double the amount that he started with. Now we're going to do the same thing for Michael. Capital A equals 2,000, which is the initial one, times 1 plus 0.0825. Now this is going to be elevated to the 14 years. So that has to be more. Because it's going to keep his money in the bank 5 years extra, right? So if you put that in the calculator, you will get 6,000 with $67.65. So you can see it triples, because it started with 2,000 and has more than triples. So now we have answer how much money each boy is going to have in his account. So he will have $6,067.65 at the end of 14 years, and James is going to have $4,082 with 8 cents. Okay. So now we have another part. It says, how much money did Michael receive than James? Remember, Michael have more money than him. So the only thing we have to do is just subtract. So we know that Michael did more. So $6,067.65 minus $4,082.08, and that will give me, or that will give us, a difference of $1,985.57. So that would be the answer for that. That's how much money Michael made than James. All right? So far, these first two problems, even with the do now, actually the first three problems has to do with growth, okay? We have add the rate. Now take a look at number 4. Number 4, it says, a new car that costs $25,000 depreciates. So depreciates means decay, means it loses values, okay? So it's gonna go down at a rate of 8%. So if you notice, here we have the initial cost, which is A. The rate is 8%, which is equals to 0.08 if you divide that by 100, and T here is 4.5 years. So you don't have to do what I did over here, like specify the value of each variable. You can just identify the variables on the problem and just plug in into the equation. So big A, which is the total amount or the final amount, equals little a, which is the initial cost. That's $25,000, parenthesis 1, but now because depreciates, because it is a decay, it's going to be minus 0.08 elevated to the 4.5. I'm going to do that because it's minus, but it's the same process. Instead of putting plus, you're going to put minus. All right, so let me do it here in the calculator so you can see. I'm going to turn that on, and I'm going to write $25,000, parentheses 1 minus 0.08 elevated to the 4.5. All right, and if I do enter, that's my answer. What did I do? Oh, I added, it's supposed to be minus. My bad, guys. See, I'm losing it. I will add today. 1 minus 0.08 close parentheses elevated to the 4.5. If I do enter, so that's most likely, okay? Because if you noticed before, the number was great. It was more than what the car was worth, and that's impossible, because cars don't appreciate. Cars always loses value. If you go to the dealer and you buy a Mercedes for $60,000, to the following day or next week, if you want to return it, if you want to sell it, that's going to cost less because you're already using it. So you know that. That's a hint, all right? The only thing that grows and values are investments. Well, it depends, all right? But if you invest something and you're making money, then it goes up. Or, like mortgages, like houses, they go also. Real estate increases in value. Real estate, talking about houses, buildings, stuff like that. So let me answer my question now. So the answer here should be then $17,178 with 50 cents. Because remember, you have to run it to the nearest cent, and the cent here is 9. But now think about, if you add 1 to 49, you will get 50. So a lot of people get confused because they keep writing 410. Because when you add 1 to this 9, you write 4, and 9 plus 1 is 10. You don't write 410. That won't be 100th. That will be 1,000th. So the answer here is what you said before. So the car will cost after 4.5 years $17,000. I mean $17,168 with 50 cents. So clearly you saw that from 25 to 17 is a reduction. So it's a decay. All right, so I guess let's turn our page to the next side. All right, so let's see what our questions are right here. Let me just set up my paper so I don't have to, keep folding it when I'm working with you guys. All right, so Now we have another problem that it says a huge ping pong tournament is held in Beijing, okay, with 65,536 participants at the start of the tournament. That means that's going to be your little a because that's the beginning amount, okay? The initial amount, remember. I'm going to write here so you remember that. Okay. Now, each round of the tournament eliminates half the participants. You're probably saying, so what's going to be the rate, mister? Because I don't see a number. I don't see like a 20%, like 5%. I don't see anything like that. But this is your percentage. Eliminate half. 1/2 is like saying 1/2, which is equals to 50%, all right? And if we divide that by 100, that should be 0.5. So there is your rate, okay? Now, because we're not talking about times, we're talking about, like rounds. Here, rounds is gonna be like your, let's say, your T, okay? Because remember, for the formula, you're looking for the formula, you're looking for the little a, you're looking for R, and you're looking for T. And another time you think that T has to do only with times, but depends what kind of problem we're working with. And according with this, we're working with a competition, with a tournament that is based on the rounds, okay? So P of R, that's like saying big A, okay? In the Vienna formula, I'm just making the connection, right? So you have to use what's given to you, but for you to to not get confused, think about that, right? So P of R represents the number of participants remaining after R rounds of play, okay? That means each round, half of the people have been eliminated. Write a formula to model the number of participants remaining. That means that we're not solving, they just want us to write the formula, okay? That we can use to find how many people or how many participants are left after each round. So if you make the connection, okay? So, for the formula, okay? A equal, and also because that says elimination, that's a decay. So that has to be minus, okay? So you think about, okay, my formula says little a times 1 minus R to the T. That will be, if I use my formula the way it was presented in the other side. So think about A is P of R. So you're gonna write P of R equals, what is your little a? That number right there, 65,536 times 1 minus, because it's a decay. What is the rate? 50%. That means 0.5 elevated to the T. What is the value of T here? The value of T here is R, because everything depends on R, not on T, okay? So that will be the formula right there. That's all they're asking. Now, in part B, they're asking you, use your model, okay, this right here, to determine how many participants remain after 10 rounds of play. Now, I'm giving you the value of R here. I'm telling you the R equals 10. So what I'm going to do is I'm just going to write the same formula, and I'm just going to substitute R for 10. So that will be P of 10, because this is my value of R, equals 65,536 times 1 minus 0.5 elevated to the 10th. If I put that in the calculator just the way it is, remember I'm evaluating, not graphing, is going to give me 64. That means that after 10 rounds, we have 64 participants left. That would be your answer. And let me just do it for you, all right? You're gonna do one more, so I will go to turn it on, clear that up, 65,536 parentheses 1 minus 0.5 elevated to the 10th, right? I only wrote my numbers, and I do enter, and it's 64. So after 10 rounds, from 65,000 people, right? More than 65,000 people, they start playing. There's only 64 participants left. Okay. So now the question says, let's see, how many rounds of play will it take to determine the champion ping pong player? So now we're looking for the winner, right? Now remember, if you do your table, okay, your X and Y's, remember, these are your rounds, okay? And Y means participants. Okay? So just take a look at the previous question. After 10 rounds, we have 64 participants. So that means that X is 10 and Y is 64. So what do we have to do here? Because the participants represent by the letter Y, so we have to find the winner. So we have to find how many rounds will it take the tournament to come down to one player, which is gonna be the winner. So in this case, guys, okay, if I use the formula, okay, you know that R represents the rounds. So if I substitute, because that, if I want to find out the value of R algebraically, we're supposed to do some topics called logs. And logs are taught in algebra 2. I mean, in trigonometry, not algebra 1, year 2. It's in algebra 2, which is after geometry. So, because we're not going to teach you that lesson, so the best thing for you to do is just to graph the original equation, all right, and look for the value of X when Y is 1. So I'm just going to use this formula, and now I'm going to graph it, okay? Now to graph it, remember, I'm just going to convert this to my standard formula for graphing. P of R is like saying Y, okay, equals 65,536 times 1 minus 0.5, and the R is like X. I just converted this exponential formula using X and Y's, so I can put it in the calculator. So in this case, the only way for now that you can do that is by graphing. So now let's go to Y equals. Now, if we clean the memory, remember, which I always recommend, when you graph and you go to the table, you're gonna begin from 0. So let's do that again, okay? Second plus 712. So my RAM is clear. So let's go to Y equals, and I'm just gonna write this equation that I just copy here, all right? So I'm gonna write 65,536 parentheses 1 minus 0.5 close parentheses elevated to the X. All right. And now I'm just gonna go to the table. Okay, second graph. And you see what's happening? At the beginning of the tournament, there was this amount of participants. After the first round, there was only half of them because half of them got eliminated. After 2 rounds, half for that one. So what's happening here, you're dividing everything by 2 because it's decreasing. If that would have been increasing, it would be multiplying this number times 2. So I'm going to continue because I have to find when the value of Y is 1, the winner. Okay? Look what I just looked before. They asked me, right? How many rounds will it, how many participants will be after 10 rounds? Look, after 10 rounds, there are 64 players, which is what we actually did in part B. After 10 rounds, there were 64 players. You could have done it this way too, but to do it this way, you have to create the formula, right? So now let's continue. After 11 rounds, there's 32 left. After 12, you see you dividing it by 2, there's only 16. So after 11, it's going to be 8. After, 11, it's increasing. After 14, it's going to be 4. After 15, it's going to be 2. And after 16 is 1. So the winner will be this one. And if you continue, there's going to be error. You never, when you have exponential, you never cross the x-axis, so it will get ugly. So that means that to find the winner, we have to play 16 rounds. So the answer for that one is going to be 16 rounds. You don't have anything like that on the homework, guys, so don't worry about it. Most of the homework are multiple choice, so you'll be fine. All right? We're almost there. We have, I guess, 3 more, but this one are not too difficult. Now let's do number 6. Let's say you're taking a medication, all right? And the medication that you're taking is represented by the letter D. That's the dose. It can be 50 milligrams, 100 milligrams, 300 milligrams. That's what the dose, that was dosage or doses represents of a particular medication. Then this is the formula that they use, to find how many milligrams you're taking or how many times you're gonna take it to finish the medication, So this formula right here, it will help you to find whatever is being asked. So that formula represents the concentration of the medication in the bloodstream, T hours. So that means T in this case is time, which is the same thing as X. Remember that times is always X. Now, if Mrs. Ryan takes 200 milligrams, that's her doses, all right? 200 milligrams of medication at 6 o'clock in the morning. So, okay, that's a scenario. Based on that, the question says, how much remains in her bloodstream at 10 a.m.? So the question is, how much of the medication remains in her bloodstream after 10 a.m.? So obviously this guy is decay, remember, because you see here 0.8. That means that to get 0.8 to 1, we subtracted 0.2, okay, to get 0.8. So another hint is going to be this. When you have multiple choice questions, if it's presented to you like this, if the number inside the parenthesis is less than 1, it's going to be a decay or reduction. If the number inside the parenthesis plus 1 or more than 1, it's going to be a growth, all right? Because so far, you see the way I put it here, I wrote 1 minus 0.5. But if I continue, if I go one more step ahead with this one, I can also write it like this. 65,536 equals to 0.5 to the R. That's what they did here. So to get to 0.8, what they did was they do 1 minus 0.2 to get to that 0.8. So if that would have been plus, then this should be 1.5. So remember that. If whatever is in the parentheses is less than 1, it's a decay, a reduction. And if it's more than 1, it's an increase or a growth, okay? All right, so let's go back to this one. So the question says, how much remains in the bloodstream at 10 a.m.? So the same formula, right? So at 10 a.m., that's represent the time. But remember, T is not gonna be 10. How am I gonna find T? Okay, to find T, right, what you do is, okay, you took your first doses at 6 o'clock in the morning. And your next one, and you're looking for how much is left in your bloodstream at 10. So you have to subtract 10 a.m. minus 6 a.m. and you get 4 hours. So that means that here T is equals 4. Now, what was your initial amount? The initial amount is 200 because that was when you took your first medication, your first doses. Or your first dose, I don't know if you say dose or doses, anyway. So let's use the formula and solve, okay? So now I know that the time is 4. So you can write f of t or f of 4 is the same thing. It doesn't make any difference as long as you use the 4 right here. That's the most important thing. So d is the same thing as saying the value of a. Remember, and a is 200 times 0 0.8 to the fourth, okay, because the time here is fourth. And if you put that on the calculator, you're going to get 81.92 milligrams. That's how much medication still in your system after 4 hours. So when you took it in the morning, 6 a.m., you swallow and you had all 100% of the medication. After 4 hours, almost 20% is like you probably expelled it out of your body or it's out of your system, all right? Okay, so now let's go to part B. How long does it take for the concentration to drop below 1 milligram? This is like a little hard question, guys. Listen, you don't worry about this, okay? Because like I said, you're not gonna see this type of question on the test or on the regions. Most of the questions are multiple choice, but it's good for you to understand, the difference between a growth and decay. So here, to drop below 1 milligram, that means, remember, we're looking for how long does it take. So we're looking for time, okay? And in the exponential functions, time is always an exponent. It's always the value of x. Always that's the time. So to find times algebraically, you have to do what I told you before. You have to use logs, which is a different topic that you're not going to see in Algebra 1, okay? So your best shot is, guys, just to graphing this in the calculator and just go to the table and see when the dose drops below 1 milligram. And here we go again, just like the one we did before. Think about it. You have your x and you have your y. X has to do with time, right? And we're talking about hours, right? I think, hours. So, x is your time. So y is your milligram. So y is your medication. So therefore, we're looking for something for the time x when y is below 1, okay? So what I'm going to do, we're going to graph the function, but remember, now we need to have like a general function. And your general function is supposed to be something like that, okay? All right, so let's write it, because here we have a formula, but we have to add the value of A here, or the value of D, which is 200. So the formula will be y equals 200 times 0.8 to the x. All right? So it's pretty much the same thing. The only thing is in here, they didn't give you the amount in the formula, but they give it to you in the problem. So you should do that for that. And in this case, I'm going to make my general formula that I can use. So if I put on the calculator, look, I'm going to type, okay, y equals, let me eliminate that. And I'm going to write, let's clear the memory. Remember what I said before, guys, okay? Let's clear the memory. Second plus 712. So I go to y equals, and I'm going to put 200 parentheses 0.8 elevated to the x, okay? And I'm going to go to my table, second graph. And look, if you notice, okay, the dose is going down. So you have to look when the value here is less than 1. So let me keep going down, going down, going down. Remember before the question, okay, that they asked you in 4 hours? Look, when it was 4 hours, it was 81.92. That was the one that we found in the previous problem. So everything can be also found on the table. So let's keep going until we get, see, it's going down and going down and going down and going down and going down. I'm concentrated here on the y values, okay? And I found it right there. See? Because in 23 hours, you still have a little more than 1. You have 1.1806. Even if you have 1.001, you still have to go to the next step, because the question says less than 1, okay? So every little thing goes above 1, you have to go to the next one. So in here, it should be 24. because when you have 24, let me write that here, you got 0.94447, and if you have 23, you have 1.1806. So I got this number from the calculator. So you can clearly see that when the 23 hours, you still have more than one. So it has to be 24. So that should be your answer. So you should write 24 hours. So it will take you 24 hours for your system almost to eliminate all the medication that you have taken. All right? So that's for question number 6. Now we'll go to question number 7. Question number 7 is not bad, okay? The number of controlled laboratory environment increases at a rate that doubles every hour. So this is your rate, double. That means, guys, that it's increasing. So every hour, it doubles up your initial amount, okay? Initially, there are 100 bacteria in the culture. The function, okay, they give you the formula already, but look, in this time, they give you the initial point amount here. In the one before, they did not give it to you. They just give you D. So you have to find D in the problem. Here, they already given it to you in the equation, in the problem, and in the equation. So it's easier. That provides the relationship between the time X, so that's about time, and the numbers of bacteria on the in the culture. Okay, so F of S means the bacteria. So just for you to know that just bacteria, it's right there, and this is your hours. Okay, look, you don't have to put this on the table. You don't have to graph to find the values of Y. You know why? Because I'm telling you that it doubles up. So what is your original amount? It's 100. So if that doubles after 1 hour, that will be 200. And if you double that up, that will be 400. Because remember, it's getting double. If you double that up, will be 800. And that will be 1600. Double up means like 100 plus 100 is 200. 200 plus 200 is 400. 400 plus 400 is 800. 800 plus 100 is 1600. So instead of doubling up, just multiply. 100 times 2 is 200. 200 times 2 is 400. 400 times 2 is 800. 800 times 2 is 1600. And just keep continuing like that. Just multiply times 2. So, but let's see if you don't see that. All the action is just graphing. So you go to Y equals, eliminate that, and just put the equation. 100 parenthesis 2 close parenthesis elevated to the X. Okay, that's how your equation will look like. And if you go to your graph, to your table, second graph, now we have to go back up to 0 because I didn't clean the memory, but that's okay. You can just move your cursor, and it's right there. You see? 0, 100, 400, 600, and 1600. So if I don't do that mentally, I can just put it in the calculator. So now that we have the information, let's graph. Now, be careful. The hours go on a scale of 1, okay? But on the y-axis, on a scale of 200. Because if that's 400, that has to be 200. So that has to be 600. That has to be 1,000. And, and that has to be, I believe, whatever, like, you can believe that will be 1,400 out, 1,400. And that's 1,600. So my first point is 0, 100. So if you don't do that, a lot of kids will start from this point right here, thinking that that's 100, and that's not true. That's 200. So 100 will be like between 0 and 200. 1 and 200. So that will be on the line. 2 and 400 should be on the other line. 3 and 800 should be right here. And 4 and 1600 should be right there. So you can see how fast it's growing. Look, from here to here to here to here, it's getting big. All right. So now that we got that, let's connect the points. And that's our graph. All right. Now, they ask you to use the results to estimate when the culture will reach 1,000. Okay, bacteria. So if you go to the equation right here, you can see that 1,000 is right here. Okay. So that will be the equation of y equal 1,000. That's a linear equation because now we're looking for this point right here. But if you go down here, you're not exactly sure what it is because it's not 3.5 because it's not in the middle. So it has to be something between 3 and 3.5. It could be 3.1, 3.2, 3.3. Okay? Now, the answer here is 3.2 hours. Now, how will you do that? To do that, you have to graph both equations, okay, and find the intersection point. Again, I'm going to show it to you, but don't paranoid, guy, okay? Because you're not going to see anything like that on the quiz or on the test or on the region. We haven't seen this type of question. You can just put it on the calculator. So let's just eliminate those, all right? And let's clear our memory. Second plus 7.12, and it's clear. Now remember one thing also, when we have a like word problem, we always have, okay guys, we always have what? The positive numbers or quadrant 1 only. So if you want to have a better window, you can, adjust your window. Okay, so let's just put the equation first. Y equals 100 parentheses 2 close parentheses elevated to the x. And on the bottom, I'm going to write the other equation, y equals 1,000. All right? Okay. So if you graph that, look what's going to happen. You're not going to see, you can see because it's so big that you don't see the other graph. You don't see the intersection point. So what you have to do is adjust your window, okay? Again, don't worry about this. You did this before. So you're going to window. We don't need, the minimum is going to be 0, all right? X is okay by 1. On the Y is going to be a minimum also, but now is highest. If you notice, how high are we going here on the, based on your graph? 1,600, right? So you can actually make that window 2,000 if you want, okay? So if I do my maximum 2,000 and I divide that by what? By 10, right? Which is to find the scale. Remember that I always tell you to divide by 10. So that will give you 200. And now you do graph. Now, see the intersection is right there. Still not quite of clear. So you have to continue playing with the window. And what you can do is, what did I do in the other one? I think the other one I made it 20,000. Yeah, if I do that 20,000, 21, 2, 3. And I think I made this one 2,000. 1, 2, 3. I think we'll be able to see it better now. What happened? If the other one works, how come it's not working here? 20,000, 2,000. That's strange. Because it worked for me in the other one. All right, so playing with the window is crazy. Minimum 20,000, but how come it didn't work? Did I do 200? If I did 200, okay, guys. I don't want to waste all more your time, but you know what? That's the answer is 32. I guess my brain is getting burned too, so you don't have to worry about that, right? Okay, now let's do this one. This one is easy because you can just put that in the calculator. Okay, if you put that in the calculator, write it as a y equal 50 parentheses 2 to the 2 to the t, and you're going to find the value of y when x is 0. That's going to give you 50. That's going to give you 200. And that's going to give you 3,200. Okay? This is bacterias. Okay? Bacterias. Bacteria. I'm going to do it quick. Okay? If you put here 50 parentheses 2 elevated to the 2x, all right? And if you go to this table, second graph, you can find it over there. Okay, where can you see the number there? So when t is 0, y is 50. When t is 1, that's 200. And when t is 3, is 800. I mean, 3 is 3,200. What did I look here? Oh, 3,200, right? Because it was 3. We skipped 2, right? So when it's 2, it's actually 800. All right? So that's it for today, guys. Remember, we have one more lesson after this, and we'll be done for the year. And again, the homework for this class, for this topic is multiple choice. You should have no problem. Maybe a couple of questions that you have to do a short answer, right? Just stay healthy and good luck.